Okay, Lamai. Let's discuss the question number 20 appearing at the page number 34 of your tute. Right, actually, that is the 2020 A level question. Right, let's discuss that one. Right, okay. So, what they are saying. So, you have the solid X which contains copper sulfide and the actually that is cupric sulfide and the cuprous sulfide, no? Cu2s and the Cus. And the following procedure was used to determine the percentage of Cu2s, right, in X. Okay, so they are saying you have a sample X, right? This is a sample X. There you have the Cu2s and Cus, right? Cu2s and Cus, right? And you are taking 1 gram of the sample. You are just taking 1 gram of the sample, right? You are supposed to copy the percentages of these two guys. Basically, the percentage of Cu2s, sorry. Right. So let's assume the number of moles in 1 grams of the 1 gram of sample X, the number of moles of Cu2s as X moles, this as Y moles, right? So if you can find out this X, we can convert this moles to its mass with the use of its g mole minus 1 value, the molecular weight, and then we can copy the percentage, right? That is what we are supposed to do here, right? So the first thing we need to write here is actually let the amount of Cu2s as X moles and amount of Cus as Y moles, right, in 1 gram of sample, right? Okay, right. So you clearly see as only the Cu2s and the Cus are there in the sample, only these two guys are there. That means we have a data point here. We have a data point here. Some numerical value where we exactly know the amounts of the chemicals in it, right? So 1 gram represent the mass of this thing plus the mass of this thing, right? So that is our first simultaneous equation here, right? So let's write that thing, right? So the first simultaneous equation is for actually for the mass of sample X, for the mass of sample X, for mass of, right, sample X in grams, right? So for the Cu2s, the molar weight of the Cu2s is actually copper carrying the 63.5, 63.5 into 63.5, that twice is equal to 127, and some 32 is there, right? 27 and 32, right? That is 159, the g mole minus 1 value. And for the Cus, it is 63.5 for the copper and sulfur 32. So altogether 95.5, no? The molecular weight of Cus is equal to 95.5. So we can come up with the first simultaneous equation here, right? First simultaneous equation for the mass of the sample, right? It is the mass of the Cu2s plus the mass of the Cus, right? You have X moles of Cu2s and 159 is its G mole minus 1 value. So its mass is going to be 159 G mole minus 1 into X moles, right? So that is 159X in grams. So 159X is the mass of Cu2s, and the mass of Cus is going to be Y moles into the 90 Y moles into 95.5 G mole minus 1. So moles cancel off to give you the mass in grams, right? So that is going to be 95.5 Y. That summation is equal to 1 gram here, right? That is your first simultaneous equation, right? That is your first simultaneous equation, right? So we need to come up with another simultaneous equation to completely solve for these two unknowns, right? Okay, let's go through the procedure to come up with the second simultaneous equation. See what they are saying. They are saying that 1 gram of this portion, 1 gram portion of X was titrated with 100 cubic centimeters of 0.16 molar K-4 in a dilute H2SO4 medium. What they have done is actually they have added this thing, right? To a titration flask, right? To titration flask, and they added the sulfuric and the K-4. That means acidic K-4 is added. Simply, the acidic K-4 is added, right? So we can come up with like this. So you have the Cu2s in 1 grams and the Cus. So the amounts are actually X moles and Y moles, right? To that K-4 is added. To that K-4 is added, right? Acidic K-4 is added. So dilute H2SO4 means acidic medium. K-4 is added. K-4 means K plus and the MnO4 minus, right? How much? The added amount is 0.16 molar solution, right? I'll write it here, 0.16 molar, and the concentration is that 0.16 is the concentration, and the volume is 100 cubic centimeters, right? That amount of K-4 is added. So first, let's discuss about the reactions involving here, right? Before going through the procedure further, right? Let's discuss about the reactions involving here, right? So we definitely know that, right, the K plus is not going to involve in redox reactions. K plus won't involve in redox reactions as it's a S block guide, right? Here, the MnO4 minus in acidic medium is going to, right, reduce to produce the Mn2 plus, right? In acidic medium, MnO4 minus reduces to produce the Mn2 plus. It's a reduction, right? The plus 7 oxidation state here of the manganese converts to the plus 2 oxidation state here. It's a kind of a reduction, right? So we are thinking of oxidations to occur in this flask, right? Oxidations, only the oxidations are possible at the flask as there is a reduction with the MnO4 minus, right? Okay. So which species are able to get oxidized here? That is our next consideration. So here you have the copper plus 1 ion here and the S2 minus ion here, right? The charges of these ions, if you consider the charges of these ions, right? This is copper plus 1 and this is S2 minus, right? That is why the formula looks like Cu2s, S2 minus and the copper plus 1, right? When it comes to here, the two ions are copper 2 plus and the S2 minus. That is why the charges cancel off to give you this formula, right? So when considering the copper plus, it is not its highest oxygen state. We know copper appears as plus 1 and plus 2. Those are the possible oxygen states for the copper, right? But here, the copper plus 1 is not its highest oxygen state. The copper plus 1 is not its highest oxygen state. So copper plus 1 can get oxidized when MnO4 minus reduces, right? So copper plus 1 will participate in a redox reaction with the MnO4 minus. What about the S2 minus? Yes, the S2 minus also not representing its highest oxygen state. Actually, S2 minus is not representing the highest oxygen state of sulfur, right? So S2 minus will also get oxidized to somewhere. Actually, in the question, they are mentioning that the products are Mn2 plus and the copper 2 plus and SO4 2 minus. That means this guy will oxidize to copper 2 plus while this guy will oxidize to SO4 2 minus, right? As the question says, right? So both of these ions in your salt of Cu2s will get oxidized when MnO4 minus is added. So that is our first reaction to think of, right? So what is that reaction? That is going to be, right, your MnO4 minus reacting with Cu2s, right? Cu2s to produce what? To produce the Mn2 plus. This guy reduces to Mn2 plus, and this guy, as the two ions, will oxidize, and the copper plus 1 oxidizes to copper 2 plus, while the S2 minus oxidizes to SO4 2 minus, right? Okay, no? So when balancing, you need to apply some 2 here, right, for the atomic balancing. So let's balance the stuff after considering this one as well, right? That is about the Cu2s situation. What about the CUS, right? So copper 2 plus appearing here is with the highest oxygen state of copper. Is with the highest oxygen state of copper, so that the copper 2 plus here can't get oxidized. If something is with its highest oxygen state available, it can't get further oxidized. So copper 2 plus here not participating in any kind of oxidation. So S2 minus ion here only get oxidized to sulfate ion, as the question is mentioning like that, right? So while the MnO4 minus get reduced, this 2 minus ion from the copper sulfide CuS also get oxidized to SO4 2 minus, right? So that is the second reaction possible here. MnO4 minus reacting with S2 minus coming from the CuS, right, to produce the Mn2 plus, and here this 2 minus will oxidize to SO4 2 minus, right? So first of all, let's balance this two stuff, right, before proceeding further, right? Let's try to balance this stuff, right? So this is carrying plus 7, right? This is carrying plus 2. So 5 electron difference, right? Here you have 5 electron difference, right? So the summation of oxygen states here is 0 because both the copper and sulfur get oxidized. The summation of oxygen states of a compound is equal to 0, right? So here you have 2 of copper 2 pluses, so plus 4 here, and the sulfur here carrying plus 6. Oxygen state of sulfur is plus 6. So all together it is plus 10, the summation of oxygen state of copper and sulfur there, right? So you will see the difference of 10 units here, 10 electron difference, 10 electron difference. So we need to balance this stuff. So least common multiple is 10, so you need to multiply this thing with 2 right? You need to multiply that thing with 2. So let's put the 2's here, and you need to multiply this one with 1, right? Just multiplying with 1, right? So that is the balancing, right? So let's complete the stuff, right? Okay, so I'll erase this one to complete the balancing, right? Okay, so you have minus 2 here, 0 here, so all together minus 2 at this side, and this side plus 4, and some another plus 4, that's plus 8, and minus 2, that is plus 6, no? Plus 6, so 8 units of difference, so 8 of H plus, and you need some 4 of H2 to balance the hydrogens. So that is the balance equation, right? And for this one, let's balance this one as well. So this is plus 7, the manganese, this is plus 2, right? The difference is actually 5 electron difference. This is minus 2, right? And this is plus 6, minus 2 and plus 6, all together 8 electron difference, no? 8 electron difference, right? Okay, so least common multiple is 40, so you need to multiply this thing with 8, right? So have to multiply this thing with 8, the manganese half, and have to multiply the sulfur containing half with 5, as least common multiple is 40, right? So just put 5 here, right? Okay, so now we are supposed to balance the charges as well as the hydrogens, right? Let's do this stuff, balancing charges as well as the hydrogens, right? So net charge here is actually minus 8 and minus 10, minus 18 here, plus 16, plus 16, and minus 10, no? Plus 16 and minus 10, right? That is plus 6, no? Plus 6 here, minus 18 here, right? So altogether 24 units of difference, right? 24 units of difference, right? So 24 units of difference, right? So you need 24 H pluses at this side. To balance that thing, you need 12 of H2, sorry, yeah, 12 of H2, right? That is okay, no? So things are balanced, no? So if you are to look at the oxygens, it is 32 here at this side, and this side also you have 32 oxygens. Thing is balanced, right? So these are the two balance equations. So as you are with x moles of this thing and y moles of this one, the consumed amount of MnO4 minus for this reaction to react with the Cu2s is going to be 2x 1 to 2 ratio, 2x, and to react with this one, it is going to be by representing for 5 by representing actually 5 portions, we need such 8 portions. So y moles representing 5 portions, right? We need such 8 portions. So first divided by 5 to get per 1 portion and multiply with 8, right? That is the MnO4 minus the amount consumed to react with the CuS or S2 minus from the CuS, right? So these are the MnO4 minus reacted, the MnO4 minus reacted amount, right? reacted amount. Right? Okay. Right. The procedure is completed up to there. Right. Let's go to the question again. Then what they are saying? Thereafter, the excess MnO4 minus in the solution was titrated. The excess MnO4 minus of your solution is titrated with Fe2 plus. The volume required was given. What they are saying? They are saying after this thing, right? The remaining MnO4 minus. That is what they are saying. Huh? After this procedure, the remaining MnO4 minus. The remaining MnO4 minus. So that means they have added in excess here. They have added in excess here. What they are saying is, after this, the remaining MnO4 minus. The remaining MnO4 minus, right? The MnO4 minus remaining, or the KMnO4 remaining. This is the remaining amount. Is actually titrated. Is titrated with the use of what? With the use of Fe2 plus solution. With the use of a Fe2 plus solution. Right? Fe2 plus solution. Right? So its concentration is 0.15. The concentration is 0.15. And the volume consumed to totally consume the MnO4 minus remaining is actually given as 35. Right? So that is our next data point. That is our second data point. Right? That is our second data point. So the amount completely consumed to react with this thing is given. Right? This is our second data point. Right? Okay, so we need to come up with a simultaneous equation for this thing. Right? So to completely solve for two unknowns, we need two simultaneous equations. So first thing is done with this data point, right? Now the second thing, right? Okay, so how to come up with this one? First of all, let's write the reaction involved in the Fe2 plus and the MnO4 minus. So we definitely know the only thing which can be done by the MnO4 minus is converting to Mn2 plus, right? So that is kind of a right reduction. So only oxidation could occur with the Fe2 plus, so that Fe2 plus will oxidize to Fe3 plus, right? The only available two forms of ion is the Fe2 plus and the Fe3 plus, right? So that is going to be the next reaction, right? So let's write that thing as well. So the next reaction we are referring to is actually the MnO4 minus reacting with Fe2 plus, right? So what happens there? While MnO4 minus reduces to Mn2 plus, the Fe2 plus oxidizes to Fe3 plus, right? Let's balance the stuff. So plus 2 here, plus 7 here, 5 electron difference between these two, 5 electron difference. These two just 1 electron difference, right? These two just 1 electron difference. So least common multiple is 5. So you have to multiply this thing with 5, no? So have to come up with some 5 here, some 1 here, right? So this is the balancing of oxygen states. Then let's balance the charges, minus 1 and here plus 10, altogether plus 9, here plus 2 and plus 15 plus 17. So 8 units of difference, so 8 H pluses are needed, and to balance the hydrogens you need 4 of H2Os, right? So that is the next equation, right? Okay. Right. So this one is our data point. This one is our data point, right? Fe2 plus is our data point, right? Is our data point, right? This is our data point. Remember that. We need to come up with the modes of this data point Fe2 plus in terms of x and y. In terms of x and y, right? That is what we are required to do, right? See, for that, first we need to know the m minus minus amount here. The m minus minus amount here. Actually, that is the remaining m minus minus. The remaining m minus minus, right? So this is the remaining m minus minus, right? This is the remaining m minus minus, right? So actually, the remaining m minus minus amount is equal to the total amount of m minus minus added minus the m minus minus consumed. The remaining m minus minus amount is equal to the total amount of m minus minus added. Total amount of m minus minus added is this amount. That minus the m minus minus consumed, right? Consumed to react with the Cu2s and the S2 minus, right? Or m minus minus reacted with these two guys, right? So let's copy that. Okay. So for the remaining amount of K minus, right? So I write it here. The total amount first of all, right? So let's copy the right total amount from here. All right, right. M for minus added total amount. M for minus added at the beginning. That is equal to 0.16 more or less 0.16 molar. How much? It is 100 cubic centimeters. I write it here into 100 cubic centimeters. That means 100 into 10.3 decimeter cubes. That amount is equal to 16 into 10 to power minus 3, no? So one can say it is 16 into 10 to power minus 3, that is 0.016. That is the total amount of M minus added. The total amount of K minus for the M minus added at the beginning. So the remaining M minus amount is actually this total amount minus the reacted amount. The reacted amount with the Cu2s and the S2 minus. That is the remaining amount of M minus here, which will be then reacted with the Fe2 plus. So we can write this value as what? 0.16 moles minus this plus this, right? 2x plus 8y05, right? That is the remaining amount of MnO4 minus, which is then going to react with the Fe2 plus, right? So this is the MnO4 minus added initially, and this is the MnO4 minus reacted. This is the MnO4 minus reacted with the Cu2s and S2 minus, right? Added minus reacted will give you the remaining MnO4 minus, which will then react with the Fe2 plus, right? So we can say is the MnO4 minus added, so that we can say MnO4 minus remaining after reacting with after reacting with Cu2s and Cus is equal to this amount, right? 0.016 minus 2x plus 8 by 5, right, in terms of moles, right? Now this amino is added minus the amino is consumed to react with the Cu2s and the Cus, so that we can come up with your second simultaneous equation for the number of moles of Fe2 plus the titration radius. That is 5 times of this thing. This is 5 times of this value, right? 1 to 5 ratio, right? 5 times of that thing, right? Okay. So I'll erase this one. I'll erase this one, right? I'll erase this to these reactions, right? Okay. I'll erase these things, right? So the second data point is going to be for this one, right? That is for the moles of Fe2 plus, right? So this is the titration, right? So that is going to be equal to this thing into 5. On the other hand, it is equal to the CV data coming from here, right? So we can write the 0.15 concentration into 35 to the power minus 3 into 5.25 into the power minus 3 in moles, right? Okay, so that value is equal to 5 times of this one, right? 1 to 5, no? So we can write 5 times of this one, 0.016 minus 2x plus 8 by 5, that is equal to this value, right? So this value, right? So that is 5.25 Newton to power minus 3, right? Let's solve for this one and come up with our second simultaneous equation, right? So here it is 5 into 16 is 80. So one can write 18 to the minus 3 from these two, right? Minus this into this 10x minus this into this. The 5 will cancel off. That will give you 8y as 5.25 into 10 to the power minus 3, right? So we can put this value here and this value see there, right? So ultimately you will get 10x minus 8y is equal to this one here, right? That is that will give you, right, 74.75 into 10 to the power minus 3. This comes here, right? So that is your second simultaneous equation, right? We can write this thing as, right, 0.07475, right? Okay, right, that is your second simultaneous equation. So one can take this one as 0.075, right? So I'll take this thing as 0.075. There is no worries, right? So those are the two simultaneous equations, right? Let's try to solve those two, right? Let's try to solve these things and come up with x, right? So I'll erase this thing, right? Okay, I'll write the second simultaneous here as well. Sorry, this is going to be plasma, right? 10x and going to the other side, it is going to be 8y, no? Plasma, right? Okay, so the second equation is then 10x plus 8y is equal to 0.075, right? Let's try to solve these two guys, right? So solving only for x is enough, Lamai, right? Because what they are asking is only for the mass percentage of Cu2 is, no, right? Let's try to solve for the x, right? So to get rid of y, so try to solve for x, right? So we need to get rid of y. To get rid of y, we can multiply this one with 8 and multiply this one with 95.5, right? And right, so that can be done. So let's do that thing, right? Multiplying this thing with 8 and this thing with 91.5, right? So and minus should be taken, right? Okay, so this is with 8, this is with 95.5, right? So number 1 multiplied with 8 minus number 2 with 95.5, right? That thing will get rid of your y values, right? 1 into 8, so 159 into 8, that will be given as 1272 x minus, right, 2 multiplied with 95.5, so that means 8, sorry, this thing, no, 10, yeah, that is 955, right? No, so these two will cancel off, no, by doing this operation, right? So this is equal to 1 into 8 is 8 minus this value into 95.5, right? So 95.5 into 0.075, right? That is equal to 7.1625, right? So this is given as 72 minus 955, that is given as 317x is equal to this value. This is 0.8375. So your x is equal to this divided by this, right? 0.8375 divided by 317, right? That is equal to, right, it's like 2.64 into 10 to the power minus 3, right? So that is the number of moles of Cu2s. So that we can copy the mass of Cu2s, right? So it's going to be 2.64 into 10 to the power minus 3 moles multiplied by its g mole minus 1 value. that is 159, no? So the mass is given as 0 point, sorry, 2.64, no, into 159. The mass is given as this multiplication will give you 490.76. 10 minus 3 is also there, so that 0.419, right? 419 grams, no? Yeah. So that is the mass of CO2s. So what we need is the percentage of CO2s, right? So I'll erase this stuff, right? So we can copy the percentage. Weight percentage of Cu2s is equal to the mass of Cu2s divided by the total weight, that is 1 grams, into 100, right? So the value is 41.9, right? So that is the answer for this question, right? So they are asking some few more questions rather than coming up with the answer. So the Roman number 1, they are asking write the balance ionic equations. We had done that thing, and yeah, based on the answers, they have asked you the stoichiometries. So that is also can be written with the use of the balance equations. And finally, the weight percentage. Yes, the weight percentage is 41.9, right now. So that's it for the question number 20 appearing in your tute, the page number 34, right? That is actually the 2020 A-level question, right? So complete your answer there.